Okay, on this lesson, I'll be doing grade 11 empirical formula practice questions. Without wasting any time, let's go straight to the questions. But before I do questions, I want to remind you guys from grade 10, you guys will be given what we call the periodic table. The periodic table, we know it has got group numbers. Also, it has got what we call mass number. So the mass number of each element that is given to you will be very important when you find the empirical formulas. For example, the mass number of magnesium, we know it's 24. The mass number of carbon, we know it's 12. Mass number of oxygen, we know it's 16. So here we're going to rely a lot on our mass numbers. So let's attempt the first question. So given methyl propanoate, which is an ester, you guys know about esters in grade 12 when you do organic chemistry. So we're given its percentage composition. We have been told that it has got 54.55% of carbon, 9.09% of hydrogen, and 36.36% of oxygen. The molar mass of the compound were given as 88 grams per mole. That will be very important later on. So on this example, we are firstly asked to define what is empirical formula. So they're asking us to define what is an empirical formula. So the empirical formula, that is the simplest whole number ratio of elements in a given compound. So I'll repeat again. So to define empirical formula, that is the simplest whole number ratio of an element in a given compound. That is your empirical formula. It's the simplest whole number ratio of an element in a given compound. Just put it down for you guys. That's the simplest whole number ratio. That's the simplest, because we always get this type of questions in exams of defining what is an empirical formula. So that's the simplest whole number. The simplest whole number, just go up a bit there, whole number ratio, simplest whole number ratio of an element, whole number ratio of an element in a given compound, of an element in a given compound, of an element in a given compound, element, let's squeeze it there, yeah, in a given compound, in a given compound, in a given compound, that is that. So from there onwards, that will be your definition for empirical formula. And the good thing is that this definition always comes in nearly every test or every exam, so you guys are bound to get that 2 mark. So now let's go to 6.1.2. Determine by calculation the empirical formula for the given compound, which is having carbon, hydrogen, and also oxygen. So to find the empirical formula, we'll use this formula, which is there in the formula sheet. So we need to find the number of moles. So it will be N is equals to M over the bigger M. So M is mass, and then the bigger M will be that one. So let's find for each. Let's find for carbon first in that order. Let's find for carbon first. So to find the number of moles for carbon, so the mass will be this one, which is given as 54.55. So the M will be 54.55. Then it's already going to be in mass, grams per 100, and then over the big M will be the molar mass. So the molar mass will be the mass number that you're having of carbon. The mass number of carbon is there in the periodic table. So mass number of carbon, we know it's 12. So from there onwards, just need to go and find 54.55 divided by 12. 54.55 divided by 12. Okay, I'm gonna leave them in 2 decimal. So I'm getting 4.55. So I'm gonna leave them in decimal. I'm getting 4.55. That'll be in mole, because that's the number of moles now. So I'm getting that for carbon. Then let's go in that order. Let's go for hydrogen, which is the second one now. So the M of again in this instance would be 9.09, and then over mass number of hydrogen, it's now 1. It's 1. So meaning this will just come back as the number, which is 9,09 mole, because the mass number for the n is 1. So it'll come back as that over that. And then lastly, we have oxygen. Oxygen is given as 36, 0, so 36,36, and then you divide that by the mass number of oxygen, which is 16. Yeah, 16 is the mass number of oxygen. Then let's find that now. 36,36 divided by 60. 36,36 divided by 60. That's giving me 2,27. That's giving me 2,27 mole. So I'm getting 2,27 mole as my oxygen there. That's fine. So whenever you get these numbers, your next step now is to do what you call the ratios. So the ratios will be, I'm going to have C there, just put a gap there. I'm going to have C there, then I'm going to have H there, because the aim is to find the ratios. Then I'm going to have O as the last one. So how this works is that the number that you got for each will divide the lowest number. The lowest number that we got here was 2,27. So meaning you divide each number that you got in these three answers. You divide each number that you got here with the lowest number, which is 2,27. Don't forget, you divide each number that you got. For example, for carbon, we got 4,55 as our answer. So you will divide that by the lowest number, which we got was 2,27 in this instance. So divided by 2,27. And then for hydrogen, same concept. You will divide the answer that you got, which is 9,09. You divide that by the smallest number, which is what? 2,27. So you divide each by that number. And then lastly, oxygen, same thing. We got 2,27 for oxygen. And then you divide that by the lowest number that you got, which is 2,27. So you divide each by the number that you got, which is the lowest number. Then now let's get the values now. 4,55 divided by 2,27. 4,55 divided by, let's do them one by one. 4,55. 4,55 divided by 2,27. That's giving me 2,00. That's same as having 2. It's 2,00. So just give it as 2 now. It's giving me 2,004, and then 2 zeros are fine there. 9,09 divided by 2,27. That's giving me also 4,00, which will just come back as 4 as well. Because it's giving me 4,00, so just come back as 4. And then same number over same number, we know that will come back as 1. So in maths, whenever you divide the same number, just come back as 1. So I've got those values now. Therefore, our empirical formula, therefore for C has got 2 in the empirical formula. H, we know it has got 4 in the empirical formula. And then lastly, it's oxygen, which will be having 1. Just put as O1. Or for those ones who don't want to put like that, you can just leave it like this. It'll be the same thing if you just go and put like this. But it's fine, just put them as 1. Yeah, don't need to put oxygen as O. O1 is fine because it represents the O1. So that will be your empirical formula for that question, which is 6.1.2. So that is our empirical formula. It's C2, H4, and then O1. That's our empirical formula. So first thing first, you divide the given value by the molar mass of each compound, like we did here. You do for C first, get the value, then you do for H, get the value, then you do for O, get the value. Second step, you get the ratios. The value that you got for each, you divide by the lowest number that you got in the 3 that you got. Then the value that you're getting, that will be your ratios, meaning C was 2, then H was 4, and then O was 1. That becomes your empirical formula. So lastly, they want us to find the molecular formula. Okay, so to find the molecular formula, you use remember we're given the molar mass of the compound. So to find the mass number, use the molar mass of the compound. We're given the molar mass of a compound, which was 88 before. So to find the formula or the molecular formula, let's just call it MF now. That's for 6.1.3. So find the molecular formula, that's 6.1.3 now. So to find the molecular formula, so you just need to go there now and let's put dots there. So to find the molecular formula now, you just need to take the given molar mass of the compound. So you take the molar mass of the compound, which is the molar mass of the compound. So you take the given molar mass of the compound, the given molar mass which they're going to give to us. So to find the molecular formula of a compound, you do the molar mass of the compound, then you will divide that by, see, remember this is the empirical formula. So you divide that by the formula mass of that. So I'll show you guys how to find that. So you divide that by the formula mass of that, which I'll show you guys how to find it. So the molar mass we are given is 88. So to find the formula mass, to find the formula mass, that's the formula mass. To find the formula mass, it's the same thing that we do when you find the big M. So whenever you find the big M, remember you go and add each. So meaning it will be 2 multiplied by molar mass of carbon, which is 12, then plus 4. So we're going to use the empirical formula that we got to find this formula mass. So it'll be 4 times group number of, so the molar mass of again, which is 1, plus molar mass of oxygen, which is not molar mass, but the molar mass of oxygen, which is 16. The mass number of oxygen, which is 16. So you're going to use 2 times the mass number of C, which is 12, plus 4 times mass number of H, which is 1, plus mass number of O, which is 16. Then we're going to add those things. That will give us the formula mass. So it will be 2 times 12, that's 24. So that's 24 there. That will be 24 there. 24, and then that will be plus 4 times 1, that's 4. 4 plus 16, that's 20. To save time, it will be 24 plus 20, which I know it will come back as 44. So the big M of my empirical formula is what? 44. So now you're going to divide. Remember the formula was like this. So to find the answer now, we're given the molar mass, which is 88. So it will be 88 divided by the one that you just found of empirical formula, which is 44. So 44. So 88 divided by 44. So it will be 88 divided by 44 now, which is 2. So the answer is 2. So once you get the answer of 2 now, you go back to the aim. The aim is to find the molecular formula. Already you've got the empirical one. So you go to your empirical one, you multiply everything by 2, which you got now as 2. If our answer was 3 here, you'll go and multiply everything on the empirical formula by 3. But because you got an answer of 2, you go and multiply everything on the empirical formula by 2. So it will be C2 times 2, that will come back as C4. Because it will be C2 times 2, which will come back as C4. Then H4 times 2 will come back as H8. That will be our molecular formula. And then it will be O1 multiplied by 2, which will come back as O2, because 2 times 1 will be 2. So this will be your molecular formula of the compound, C4H8O2. So you need to find the molar mass are given to us. So you need to go and find the formula mass of the empirical one by doing what you do when you find the big M. Then once you get that, you divide the one that you're given by the one that you got is 2. The value that you get here, you multiply everything on the empirical formula by it. That becomes your molecular formula. So that covers that. Okay, that covers that question, and that was 10 marks. Okay. So I think for fairness, let's try another example also. So let's say now we're given this type of question. Now we have been told that the chemical composition of a compound is having that, and also that, and again the molecular mass of a compound is 2 or 4. So the same thing will apply now. Firstly, let's get the moles, the number of moles. So let's get the number of moles first before we even do anything. So we know to get the number of moles. Let's do for each. Let's do carbon here, and then let's do chlorine here, and then let's do fluorine here. So we have got 2 group 7 elements. Okay, so we're gonna find the number of moles there, and to find the number of moles, we know we're gonna use that formula again of mass over big M, which will be the mass number in this instance. So here it will be 11,79 for carbon, 11,79 for carbon, then divided by 12 now. And then for chlorine will be 69,57. And then you divide that by, now you need to go and find the mass number of Cl in the periodic table. I'm just trying to look for that one. Mass number of Cl in the periodic table. because it's good to get that one. So to find the mass number of Cl in the periodic table. Okay, the one that I'm using is 35,5. It's 35,5 there is the mass number in the periodic table. Then lastly, we're going to do same thing for fluorine. So it's going to be 18,64, and then you divide that by the molar mass of F, divide that by molar mass of F, and of F, yeah, which is 19. It's 19. So let's get the values now. 11,6, yeah, here I'm going to have a lot of decimals here. 11,79, it's going to be 11,79, 11,79 divided by 12. Okay, yeah, that's 0,98, but I feel like I just want to at least, yeah, let's do 0,898 there. And then now let's go to 69,57 divided by 35,5. That's 1, oh, this one give me a problem with 2 decimal. 1,96, yeah, should be fine. 1,96 should be fine. 1,96 should be fine. Yeah, 1,16 should be fine. Then lastly, let's do that one. So it will be 18,64 divided by 19 is 0,98 also. So it's going to be 0,98 as well. So I've got those 3 values now. So now we are sorted. We can go and do our lovely ratios. So remember when we do the ratios, it will be like this. So let's put C here, then let's put Cl there, then let's put F then to find our ratios. So remember the value that you got, you divide by the smallest number. The value that you got, divide by the smallest number. Our smallest number in the 3 answers that we got here, it was 0.98. So you divide everything by 0.98 because that's our lowest value that you got. So you divide that by 0.98 because that's our lowest value that you got. And already we know same number dividing same number, that gives us 1. Then we go to second one, it was 1,96. Then you will divide that by 0,98 for Cl there. And then same thing for F, we got 0,98. We got 0,98, and you also divide that by 0,98 because the same thing. So you must divide the same thing by the lowest number. And again, let's get the value of this one because I didn't get it. This one I already know. So if times 0.98 divided by 0.98 will come back as 1. Same number dividing itself will always give us 1. So 1,96 divided by 0.98. 1,96 divided by 0.98. That's giving me 2. So I'm getting 2 for Cl. Okay, and then therefore our empirical formula will be like this. It will be C1. That's our empirical formula, C1, and then Cl2. So it's C1 and a Cl2, and then lastly it will be F1 based on that ratio. So it's C1, Cl2, and then F1. That's our empirical formula. And again, they want us to find the molecular formula. So to find the molecular formula, same thing that we did before. Let's find the big M first, which will be the formula mass. Let's find the big M of the empirical formula. So it will be 1, which is there, multiplied by the molar mass of carbon, which is 12. 1 open a bracket, then 12, then plus it will be 2 multiplying the molar mass of chlorine, which we just found before, as 35,5. So and then plus lastly it will be 1 multiplying the molar mass of fluorine, which is 19, there. Then from there you just add the values as they are. So it will be using the empirical formula, it will be 1. This one just needs to do it quick. So it will be I think that just put them once. Yeah, just put them once. Same time. That will save us time. That will save us time doing them once. So I'm getting 102 now. So I'm getting a value of 102 there. So I got a value of 102 for that big M. So now to find the molecular formula, firstly we need to divide those two. The given one is this one, and then we divide that by the one that we just found now, and I think we get the same value as the previous one. So because we know that it will be 204 it will be 204, and then you divide that by 102 ne? To get that number which you're going to multiply everything by. And then 204 divided by 102, that should be 2. Yes, 2. So meaning the answer is 2 here. So you go to the empirical formula and multiply everything on the empirical formula by 2. So meaning our molecular formula now will come back like this. For C to be 1 times 2, which will come back as 2. Ne? So it will be C2. For Cl, it will be 2 times 2, which will be 4. So it will be Cl, then 4, because 2 times 2 will be 4. Then lastly, for F, will be 1 times 2, which will come back as 2. So meaning our molecular formula will be like that. That will be our molecular formula. C2, Cl4, and then F2. So yeah, first thing first, use the given values, divide them by the mass number, then you get those values. Once you get those 3 values, you're going to divide each of the values that you got by the smallest number, which is 0.980. Then once you get that, you get these ratios of 1, 2, and also 1. That becomes your empirical formula for each. Once you get the empirical formula, you go and find the molecular mass of it, or the big M of it, which you found as 102.2. Then from there onwards, you will divide the given value by the big M, which you found, which is 102. Then once you get that value, you go back to your empirical formula and multiply everything by the answer that you got. If our answer was 3 here, we would have multiplied everything here by 3. But because our answer was 2, you multiply everything by 2. Then that gives you the molecular formula of the compound. Just that. So that covers that. And again, if you are new to the channel, please check the playlist and see other content that we have covered, because I've done a lot of topics for physical science grade 11s. So I think check them out. And again, you can comment on the comment section which other topic you might want us to cover. I'm always open in doing any other topic. So without wasting any time, thank you very much, guys. See you on the next lesson.